TCB-VIO. Conventional cameras usually work by having the processing done on some external host PC. But for high frame rate tracking, we want to alleviate some of the processing on sensor itself, so we need a better camera system. Introducing FPSPs, where we actually alleviate some of the processing on sensor. The particular FPSP is the SCAM5, where we use the simmed and parallelized architecture for fast high frame rate tracking. You can see here on the left, we deal with a 4 degree of freedom visual odometry algorithm that was done in 2017, 2019, but these are only 4 degree of freedom. Then we dealt with a 6 degree of freedom visual odometry algorithm, but this was as well only visual odometry. And what if we dealt with more complex state estimation, like dealing with VIO? VIO is visual-inertial odometry. There are 2 types, loosely coupled and tightly coupled. Loosely coupled deals with some disadvantages, such as suboptimal accuracy and slower recovery from drift. Tightly coupled would have higher accuracy and more robust for feature tracking. There was a prior work with FPSPs in 2024, and it was known as bit VIO here on the far right. You can see that the loosely coupled VIO approach outperformed the prior middle bit VO, but it was a loosely coupled approach, and we want to deal with a tightly coupled approach now. So our method is TCB-VIO, which is a tightly coupled approach that deals with on-sensor processing of edge and corner images at high frame rates of 250 frames per second. It basically is fed into the algorithm where the binary edge image is feathered and the corners are tracked. It is then fed into a binary enhanced KLT, and it can deal with high frame rate tracking where our TCB-VIO algorithm outperforms OrbSlam3, Vince Mono, and other state-of-the-art algorithms. You can see here that tracking with no binary enhanced KLT shows that we fail in drift and high frame rate motions at the top. And at the bottom, when we deal with our binary enhanced KLT, it's very stable. And so with our binary enhanced KLT, you can see that our TCB-VIO deals with high frame rate tracking that operates at 250 frames per second, utilizing the on-sensor processing capabilities of the SCAM5 FPSP. Among other trajectory results, we show that there are failures that are present in OrbSlam3 at the right, showing pink regions, large pink regions where OrbSlam3 cannot track at all. It has very long failures, and you can see that TCB-VIO here in the colored plots still is very robust and tracked. There's also not just long failures, but partial failures, and you can see here in PX, OrbSlam3 here on the right in these pink regions, it fails, but our TCB-VIO algorithm in these cases, these fast hostile motions, still is able to robustly track.